Hello everyone, we are going to start a very interesting and very important chapter of physical chemistry, which is thermodynamics. Thermodynamics is not an important chapter of physical chemistry only. It imparts an extreme importance in overall chemical sciences. Actually, this study is the relation between heat, work, temperature and energy, and all are from the experimental facts. There is no paradox, there is no assumption, nothing. Okay, and it involves 4 laws: the zeroth law, first law, second law and third law. But before starting the law, in my first lecture today, I am going to discuss some basic parts of thermodynamics. These are actually the systems and the concepts about systems, surroundings, boundary, thermodynamic processes, intensive and extensive properties, internal energy. The concept of internal energy is very important. Reversible and irreversible processes. Okay, so let's begin our journey of thermodynamics with the definition of system. So what is a system? You are studying a system, isn't it? So a system may be a cup of tea. It's a system. A bottle of water, that is a system. Our planet Earth, that is also a system. Or our overall solar system, that is also a system. That means the selected part of the universe, what you have selected for your experimental observations. Okay. It may be a very tiny part of the universe also, maybe an electron in its orbit, that is also a system. A nucleus, that is also a system. The energy transfer between the electronic orbit and the nucleus, this is also this study is also thermodynamics. Okay, so this is a huge thing. So what should be the definition of a system? The definition of a system is defined as an object or a quantity of matter that is a part of the universe chosen for observation separately from the rest of the universe. That means the part which you have selected should be separated from the rest of the universe, and that rest of the universe is known as the surrounding. Here in the third definition you get surrounding. I am coming to that point later, but before that, before coming to surrounding, we have to know about boundary. So system is separated with the rest of the universe by some wall, and that wall is known as the boundary, or simply it is called a wall. So what is the definition of a boundary? A system is enclosed by a wall which may or may not permit energy or matter to pass through. This is the thing that encloses a system to separate from the surrounding. This is called boundary or wall. Okay, now come to the point, surrounding. So as I have said, the rest of the part of the universe apart from the system is the boundary. So what is the definition of surrounding? Outside the boundary of a system, all the remaining part of the universe is called surrounding. Now, classification of systems. Systems are generally of 3 types: isolated system, closed system and open system. What are the examples or definitions of isolated system, closed system and open system? The definition of isolated system, or the description of isolated system, is this system does not allow energy or matter to be exchanged with the surrounding. That is, there should be no flow of energy, there should be no exchange of matter between the system and the surrounding. Suppose you have taken a thermoflux, inside the thermoflux you have some hot water. So the hot water will not become cold for some time. If the situation is ideal, then for some time it will not release any kind of heat energy, nor it will not lose any kind of water molecule. It will not release any kind of water molecule to the surrounding, and there should be no exchange, and water molecule will not be absorbed from the system also. So this is an isolated system. Now move on to closed system. In a closed system, energy will be exchanged, but matter will not be exchanged. Suppose you have a bottle of water and that bottle is closed. So if it is hot water, it will come to the normal temperature. If it is cold water, it will also come to the normal temperature. That means hot water is releasing heat to the surrounding and cold water is absorbing heat from the surrounding. As a result, the energy is being exchanged energy sometimes may be absorbed, may be released. So the closed system allows energy exchange but does not allow any exchange of matter with the surrounding. So as for example of water kept in a closed bottle. Now finally, open system. So from the name you can come to the conclusion that it allows both energy and matter to be exchanged. Suppose a cup of tea, open cup of tea. If you keep the cup of tea on your dining table, then it will lose some water molecules or some tea flavoring gaseous molecules, and it will also lose some heat energy and become cold. So this is an open system. Now move on to the definition of we have already learned the definition of boundary or wall. Now come to the classification of wall or boundary. So walls are generally of two types. One is rigid, another is non-rigid. Rigid walls are actually non-flexible. That means you cannot tamper it, or you cannot make it flexible. But non-rigid walls are flexible. That means if you press it, or if you apply some force on it, it will change its shape. So these are all flexible. So walls are generally of two types, rigid and non-rigid. Rigid walls are non-flexible, whereas non-rigid walls are flexible. Now rigid walls and non-rigid walls both are of two types, and these types are permeable and impermeable. Permeable walls actually allow matter to pass and as well as energy, whereas impermeable wall does not permit matter, but it may permit energy or may not permit energy to pass through it. Similarly, in case of non-rigid walls, they are also of two types. Non-rigid walls are also one of them allow energy and matter both to be exchanged, and the second one does not allow energy to be exchanged, but it does not allow matter to be exchanged, but it may or may not allow energy to be exchanged. Now if it allows energy to exchange, it permits energy to exchange, then it is diathermal wall, and if it does not, then it is adiabatic wall. Similarly, impermeable non-rigid impermeable wall also is of two types, such as adiabatic and diathermal, and the examples of rigid adiabatic wall, it is wall of a thermoflask, whereas the rigid diathermal wall, this is the wall, this is the glass wall, example of a glass wall. On the other hand, if you try to find out non-rigid adiabatic wall, you will not find any kind of suitable example for that, but there are example of diathermal walls, non-rigid diathermal walls. And suppose a wall of balloon, the wall of balloon is flexible and it allows energy to pass, but it doesn't allow matter to be exchanged. Okay, so that's all about the classification of walls. Now move on to property. Properties are of two types, intensive properties and extensive properties. Intensive properties are actually which doesn't depend upon mass, and extensive properties which are mass dependent or amount of a substance dependent on amount of substance. Okay, so temperature and pressure does not depend upon the amount or mass of a substance, whereas V and N is the number of moles, V is the volume, these two depend upon the mass or amount of the substance. All the energy terms such as U, H, A and G, you will learn about them later. So all the energy terms, internal energy, heat content or enthalpy, work functional, Helmholtz free energy and Gibbs free energy, all these energy terms are extensive. They all depend upon mass or amount of the substance, whereas their same energy per mole, this is mass dependent, because for 1 mole the energy term is same. So in that case it becomes U bar, H bar, A bar and G bar like this. This then becomes an intensive property, becomes mass independent. So internal energy is mass dependent, whereas molar internal energy is mass independent. Similarly, the density, refractive index, surface tension, viscosity, all these properties are mass independent. If you take 1 gram of a substance or 100 gram of a substance, these properties remain the same. Okay. Now, if you combine these two properties, or if you combine an intensive property with another intensive property, suppose two energy terms, okay, or energy with something else, energy with pressure or something like that, then what happens? Let's see. Here capital letter X and capital letter Y both are intensive properties. That means capital X and capital Y are mass independent, whereas small letter x and small letter y are two properties which are extensive properties. That means they do not depend, they actually depend upon mass. Okay, now let us combine them. If you add one intensive property with another intensive property, then it will yield another intensive property. If you divide them, then it will be another intensive property. Intensive properties will also be obtained if you differentiate them with one another, with respect to one another. If you similarly, now here this part is very important. If you differentiate two extensive properties, or if you divide one extensive property with another extensive property, then intensive property will be obtained. How? Suppose let's take density. What is density? Density is mass divided by volume. Now mass is mass dependent definitely, and volume is also mass dependent. So both are extensive property, but their ratio, mass volume ratio, that is the density, this is an intensive property. Similarly, the differentiation will also yield an intensive property. Now, how the extensive properties after combination will be obtained? If you add two energy terms, then another third energy term will be obtained. Suppose you are adding internal energy with mechanical energy, so you will get enthalpy. So all these are extensive properties. Okay. If you multiply one intensive property with another extensive property, then another extensive property will be obtained. If you divide any extensive property by any intensive property, then extensive property will be obtained. Similarly, if you differentiate one extensive property with an intensive property, then an extensive property will be obtained. You can take the examples of intensive property and extensive property and try them at home yourselves. Now, let us move on to our next topic, which is very important, which is called the thermodynamic changes. There are lots of types of thermodynamic changes. Okay, these are depending upon the operations which are undergoing here. So the operations that bring about the changes in the state of a system called thermodynamic changes or processes. These are isothermal change, adiabatic change, cyclic process, iochoric change, isobaric change, isodynamic change, and so on. Isoentropic, isoenthalpic, and so on. Okay, so let's find out what about them. First of all, isothermal change. If the temperature of the system remains constant, that means delta T equals to 0. Delta T is T2 minus T1. T1 is the initial temperature of the system, whereas T2 is the final temperature of the system. So if the difference is 0, that is delta T is equal to 0, then it is an isothermal change, and the process is isothermal process. T is the temperature of the system. Next, adiabatic change. In adiabatic change, the heat energy, Q is the heat energy of the system. So if there isn't any kind of exchange of heat energy with the system and the surrounding, then delta Q equals to 0, and that type of change is known as the adiabatic change, and the process is an adiabatic process. Now, cyclic process, that part is very important. If psi is some thermodynamic function, okay, this is some thermodynamic function. Suppose this is some energy, this is a function of temperature and pressure, okay, or temperature and volume. Then for a cyclic process involving n number of steps, now you are undergoing some processes, and the number of steps you are operating is n. Then d psi is the derivative, that is small change of the thermodynamic function. Then its addition is the overall change of the system. Okay, how they are added, that means how they are integrated. They will be integrated in n steps. Okay, integration for 1 to 2 for the change of the system of the thermodynamic function from system 1 to system 2, then 2 to 3, then 3 to 4 plus dot 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 and so on from n minus 1 to n, and finally n to 1 again. So we are moving back to the first state of the system. So this way, by integrating the derivatives of the different steps of changes, then this is the overall change of the system. Now if this overall change of the system is 0, then it is a cyclic process. So for a cyclic process involving only this is a cyclic process, and now if only 2 steps are involved, then 1 to 2 and 2 to 1. Okay, this becomes d psi 1 to 2 plus d psi integration of d psi 2 to 1. This is also 0. Okay, in short, they are all written as cyclic integration d psi equals to 0. So these steps are cyclic integration of d psi, or this too is also a cyclic integration of d psi, and this is 0. So this is about a cyclic process. Now isochoric change or isochoric process. If V is the volume of a system, then V1 is the initial volume of the system and V2 is the final volume of the system. Then what is the volume change, delta V? It is V2 minus V1. And if there is no change in volume, then V2 minus V1 remains 0. Then this process is an isochoric process and the change is isochoric change. Now isobaric change. In isobaric change, pressure remains constant. Okay, so in isothermal change, temperature remains constant. In isochoric change, volume remains constant, and in isobaric change, the pressure remains constant. Now the next part is isodynamic, but before that you should have some idea about internal energy. Internal energy of a system is a very important thermodynamic function of a system. Internal energy of a system consists of 5 types of energy of the system. One is the nuclear energy, plus the electronic energy, plus the vibrational energy, plus the rotational energy, plus the translational energy. So the summation of these 5 types of energy consisted by any system, that is the energy obtained from its nucleus, the energy obtained from its electrons, the energy obtained from its vibrational movement, the energy due to its rotational movement, the energy due to its translational movement. These energies, when summed up, then a new energy term is obtained, which is called the internal energy. But the absolute value of internal energy cannot be measured. You can detect the change of internal energy, and if there is no change in internal energy, then it is an isodynamic change, and the process is isodynamic process. Now next move on to path. Path means the steps, the type of the steps, whether the steps are small, whether the steps having the property to revert back or not. So this is about the path. So what is the definition of path? Let's start. Let's see what is the definition of path. The sequence of steps. So this phrase is the key word. These 2 words, sequence of steps. Okay, the sequence of steps is actually the path. So what is the definition? The sequence of steps starting from the initial state to the various intermediate states and ultimately to the final step of the system is called the path. Now there are 2 types of paths. Okay, these paths are reversible process and irreversible process. If the path has some particular characteristics, it is reversible process, and it has some different types of characteristics, it is irreversible process. Let's see what about them. The characteristics of the reversible process are: number 1, the reversible process involves successive stages of infinitesimal quantities. Suppose you have to reach to a point which has some higher order. altitude, then you have many options. You can jump to that point, or you can use a stair or a ladder, or you can use a pole vault. Now if you use a ladder or a stairs, then this is similar to reversible processes, because there the steps are small, okay, and the characteristics of the steps is they are non-spontaneous. Okay, spontaneously, actually, suppose you are coming back, okay, you are coming from the higher altitude to some lower altitude, so preferably if you are a child, then you will definitely jump, so this is spontaneous. But if you are an old person, then you will never jump, you will definitely use the stair, so that is non-spontaneous. Okay, so the steps are small and non-spontaneous, and if the steps are small, then it has also it should have the capability to come back or revert back. So the reversible process has the ability to come back to the initial state, that is, it has the reversibility, and from this name it is named the reversible process. Okay, so if the path you are adopting, you are choosing, has small steps, has the non-spontaneity, and if it has the tendency to come back to the initial state, then that is a reversible process. And another thing, if you are jumping from some height to some lower altitude, then you will take a fraction of a second, but if you use the stair, then it will take some time. So the reversible process is very slow process, whereas you must say that irreversible process must be some fast process. Suppose take the example of oxidation, two oxidation processes. One is burning, another is just oxidation, simple oxidation. Suppose you are heating a paper, so it is burning. Okay, that is a very fast process. But suppose you go to the library and find out some old pages of old books. It is no more a white page, it becomes a red page. Due to what? Due to the same thing, the same oxidation reaction with the aerial oxygen, so it is just becoming red. So that is a very slow process. Okay, that is also oxidation, and burning is also oxidation, but burning is a very fast and spontaneous process, so that is irreversible process. But another one is an irreversible, is a reversible process. Okay, so you can easily now point out the characteristics of an irreversible process. So what about them? The irreversible process does not have the restriction to occur in successive stages. It may happen in one step or two steps. Steps are very large and spontaneous, and you do not have the ability to come back to the initial state, that is, it doesn't have any reversibility, and the process is definitely very fast. So that's all for today. Thank you.